Welcome back. Today we are looking at JCE Science. They passed the paper 2014. So let's look at question 1, section A. It says use the information below to answer question 1. Silicon is non-metallic element. Some of the properties of silicon are similar to those metal. The following is a list of some properties of silicon: shining gray in color, hard but brittle, melts at 1410 degrees Celsius, form acidic oxide. Question 1 says, which two properties of silicon are similar to those of metals? We are looking at this. Metal are shiny, most of them, the likes of aluminum. We have hard but brittle, like, so this means that it breaks easily, so this one is out, right? Metal don't break easily. Melt at 1410 degrees Celsius, that is high melting point, so high melting point, which is good. Form acidic oxide. So most of metals, they form basic oxide, right? Basic oxide. But others, they are amphoteric, right? When we say amphoteric, we mean that they can show both the basic oxide or acidic oxide, right? Like the aluminum oxide, right? So this one is out, right? Most of them, they are the basic oxide. So we are left with these two, right? So they are mostly shiny and gray in color. So that, and then we choose melt at 1410 degrees Celsius. Let's go for B. That was A. B says, what is the physical state of silicon at room temperature, right? So silicon mostly exists at silicate and it is solid, right? So they're asking you about physical state. Remember, we have what? Solid, liquid, and gas, right? But this one is what? Solid. Now they say describe the arrangement and movement of particles in silicon elements at room temperature. So usually they can use the RTP, right? When we talk about the arrangement, they are tightly packed in a uniform arrangement, right? So they are tightly packed in a uniform arrangement, right? Tightly packed in a uniform arrangement. Right? So for movement, when we look at the movement, remember this was the arrangement. So let me check for the movement. When we talk about movement, they vibrate about fixed position, right? They vibrate about fixed position, right? Now let's go for C Roman figure 1. In the space below, draw the atomic structure of silicon showing all electrons. Indicate the number of proton, right, and that of neutron in your drawing. Refer to the periodic table, right? Let me show you the periodic table. This is the periodic table, right? So our silicon is here. This is where our silicon is, right? We have the mass number here, mass number, and then we have 14 here, which is proton number, right? So we have 14 and 28, right? So for silicon, we have, remember this silicon Si, we have mass of 28 and proton number 40. Now they're asking us to draw, indicate number of proton and that of neutron in your drawing, right? So remember the electronic configuration. Remember the first shell can take 2, second 8, third 8, and this one 18, right? So we are going to take this 14, right? Remember the proton number equals to electron number, right? So we're going to start with the nucleus, right? We can write, we got 14 proton and 14 neutron, right? This is the nucleus, and then we start with this. We're going to draw our electron. Remember we've got 14 electron, right? So the first shell takes 2, right? We have 1, 2, so we are going to subtract 2 here, and then we remain with 12, right? So we are done with the first shell. Going to second shell, it takes 8, right? From 8 we are going to subtract 8, so we're going to say 1, 2, 4, 6, 8, right? Now we have taken 8, we remain with what? 4, right? We're going to draw this 4, 1, 2. You can put another 2 here, right? This is what they expect you to draw. So they say which part of atom contains proton, right? Proton are in the center. So this is the nucleus, right? Proton and neutrons are contained in the nucleus of an atom, right? So let's look at question 2. It says oxygen can be obtained in laboratory by decomposition of hydrogen peroxide in presence of catalyst, right? So whenever they are talking about decomposition, right, you are breaking down substance into its simple product, right? Now they say complete the word equation below for the decomposition of hydrogen peroxide, right? So we are having hydrogen peroxide. Remember, when we decompose, let's say we're having AB, we're going to have our product SA plus B, right? So let me try to use different pen, right? So now we are having hydrogen peroxide, right? That's H2O2, right? Now what is going to happen here is that we are going to have H2 and one oxygen bonding to this hydrogen, so it's going to be H2O, which is what, plus we have taken one oxygen and then we have oxygen here, right? So this is what the reaction is also happening here. So here we are using the symbols, right? But here they want the word equation, so let me this. So we're going to have what, which is H2 plus what, oxygen, right? Now what they are saying is that they are saying in Roman figure 2, name a suitable catalyst that is used in the reaction, right? So we can use different catalyst, right? The popular one is manganese 4 oxide. We can have what, copper 2 oxide. What else we can use? I think we can also use chromium oxide, right? Let me look for the last part, which is B. It says B, ozone, right? Trioxide and oxygen dioxide, right, are different form of the same element in the same physical state, right? Remember, with oxygen, when it is one oxygen, we say mono. So like carbon monoxide, this one oxygen, right? So we say this is carbon monoxide. When we have two, we say di. So we can say CO2 and then it's carbon dioxide, right? When it is 3 is tri, 4 is quad, right, and so forth. But here they say which term is used to describe the two forms of same element, right? We are talking about the allotropes, right? Allotropes of oxygen, right? Don't confuse this with isotopes, right? Isotopes means it deal with the chemical reaction, right? And when we talk about isotopes, we are talking about those elements that have different neutron numbers, right, but same numbers of proton, right? That is the isotopes. Thank you for joining us. see you next time. Bye bye.